And thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Where tonight we're going to take a look at some coding in the classroom, specifically trying to focus on comprehension and contextual learning. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight, I'm excited to be joined by our two panelists, Ann Schlemper and Kara Lehman. Ann is certified to teach grades 6 through 12 and has a PhD in mathematics education. Ann has been a T-Cube regional instructor for 15 years, and currently Ann's interests lie in the areas of STEM and STEAM, although her love will always be fractions. She has two children. Her daughter, Kaylee, named after the mathematician Sir Arthur Cayley, is a freshman art major in college, and her son, Isaac, named after Sir Isaac Newton, is a sophomore in high school interested in engineering. Ann, it's great to have you with us tonight.
Thank you.
And Kara has been teaching mathematics at the high school level for 25 years, and she currently teaches Algebra 2 and Calculus and enjoys every opportunity to incorporate technology into her lesson plans. Also a track and cross-country coach, Kara has a special interest in applying mathematics to sports. She enjoys working with teachers to explore ways technology can help by deeper conceptual understanding for students. Kara, it's great to have you with us tonight.
Happy to be here.
We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Kara or Ann using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event's certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the very top of the WebEx menu, and then choose Join. At this point, Ann is going to discuss our agenda.
Okay, so tonight we are going to do welcome and introductions just like you had, and yes, I'm very happy to be here as well. I really love coding on the graphing calculator and coding in general. So we're going to be writing some programs on the TI-84, and we're actually going to be sharing programs that my students have written in the courses that I teach. And these are basic language programs. And we're going to model some applications to the real world and also some to graphic design. And we hope to show you how you can use free software, which is called TI Connect, to maybe, if you're going to be writing some very sophisticated programs or really long programs, write those on that software and then transfer them to and from your TI-84. And please stick around until the end. There will be a drawing for you to win a drawing. The drawing will give you tickets to the T-Cubed International Conference in March.
Thanks so much, Ann. And one thing that I know Ann and Kara wanted me to mention is that if you want to have your TI-84 handy tonight and you feel really comfortable coding, then feel free to bring it and to code along with us. But if you don't either feel super strongly in your coding capabilities or you seem to be getting lost quickly or you don't have your TI-84 with you tonight, no big deal. In a couple of days, you're automatically going to get a follow-up email with a link to the recording, and that way you can go at your own pace. So I think Kara is going to discuss our expected outcomes.
Yes. So we're going to start by exploring some ways to get your students using simple coding to assess their knowledge of specifically function behavior, both in algebra, really algebra 1 through calculus. And we do say they're simple codes because we know that things can be elaborated on, but we're just going to try to get through several things that our students have done that's pretty simple but pretty powerful. We also hope that you can use these programs in lots of different classes, algebra, precalculus, calculus. And as things become less important to see the procedures, that the programs could be used in classes beyond where you're first learning the material. We also hope to show you a couple of ways that our students have applied the knowledge of these programs to the real world. And also, there's some pretty cool shortcuts on the TI-84 CE that we'd like to share with you in regards to programming and the TI Connect software as well.
Kara, thanks so much. I just opened up a really quick poll because I know Karen and Ann were interested on what your coding experience is and programming experience. So just a little 1 to 5, what's your experience level? So feel free to respond. And then we'll kind of share that with everyone so everyone kind of see who we have on with us tonight. Ann, feel free to share your screen.
Okay, so I first wanted to be able to share with you that these are our emails, and so if there's something that we can help you with later on as you start programming in your classrooms, or if you have some ideas you'd like to share with us, please contact us. And so there's our emails, and it's also at the last slide as well. But again, as Mike said, you will be receiving all this information in a follow-up email. And so what we'd like to ask you first in the chat is, why do you think it's important to teach kids to program in a math class? And I'm going to go ahead and let you answer that in the chat room. But in the meantime, I'm going to tell you a little bit of why I think it is, and so is Kara. So I learned to program in the late 80s. So I was programming many languages that are not even used anymore, like COBOL and Fortran. But I decided to just minor in computer science and major in math, but I still have a very big passion for programming. And I wanted to know if I could incorporate these ideas and my passion for programming with my students. And I soon learned that it's pretty easy to program on the TI-84. And so I began to do those things with my students, and my students loved it. And they developed that passion. And so they would say, hey, seems like we're doing the same thing over and over again. Do you think we could write a program to do this? And they would write the programs, and it would not be me writing the programs, it would be them. And so I really find that empowering for them. Kara, would you like to? Yeah.
Yeah, absolutely. So for me, I think I've seen a big change in motivation for students. To me, it's just more of a puzzle for them to solve. So if you have something very algorithmic, that can be somewhat boring to some students. If their program isn't working to do what they want it to do, then it becomes more of a problem-solving exercise, and they become more motivated to do what you're asking them to do.
So do we have any comments coming from any of the participants?
Not yet.
Okay.
Well, yep, teaches perseverance, I see. Yep.
Perseverance, that's good.
And actually, Kara and Ann, if I could jump in really quickly, we have a lot of people sending their chats in, but some of them are sending to all attendees and not all participants. So if you can make sure your chats go to all participants, that way Ann and Kara will see them as well. Thanks.
Okay, well,
yeah, and people are mentioning too, and the idea of structuring things and seeing the logic behind your algorithms, giving deeper meaning.
I'm starting to see some of them pop up now.
Mm-hmm.
I'm starting to see the chats pop up now. Okay, so I've seen a lot of things that are similar to some of the things satisfaction, logic, order, structure. So that's a lot of the things we put here, similar. Do you want to go through these, Kara?
Sure. So I think people have already kind of mentioned these things, but if you're just listening, maybe you can't see it. Some ideas in mathematics are routines and procedures, like we said, to make it more exciting, more problem solving, help them see the structure. Those are all good things. Kids are taught to rotely memorize procedures, and then they forget them. But when they're forced to write a program, they often don't forget. Conceptual understanding is necessary in order to remember things for a longer period of time. And then being able to break down the steps of a procedure into a programming language can lead to that conceptual understanding that we're after.
Okay. some of the things that my students have done in the classes I've taught. Now, I did teach in the high school for a long time, but now I teach at the college. But I teach both math and math education, and I teach at a very small school, so I get to teach a variety of classes. So we've done things like systems of equations, quadratics. I teach calculus. I teach college algebra. So these various things we've written programs for. And again, these are my students' programs, and so they're not always the most elegant because they aren't computer science majors. And so I'm going to share with you these pretty raw, basic programs that you could make more elegant if you were a computer science major. And as my computer science teachers used to say, maybe more user friendly. But if the students, write it and it makes sense to them, I think that's the important thing, and they can apply it and use it to solve mathematical problems. So as you look at these, keep in mind these were written by my students, not by me. So the first, we're going to share some Common Core standards with you.
Yeah, so we're not going to read these to you necessarily, but we're hitting some of the standards from the functions category or domain, and we're talking about linear functions tonight, and some of the procedures are going to involve solving systems, identifying in behavior, identifying asymptotes, and showing how the solving of systems, I guess we didn't put that one on there, Anne, but the other things are all kind of more geared towards the function domain.
Yes. Okay, so the first one here, I think we have a question to give you is, here is a system of linear equations. It's if you teach Algebra 2 or college algebra, this is a very common question you might see given to your students or ask your students to solve. And I think that Mike has a question for you to answer about this.
I do, and just before I open that poll, I just want to mention that I just want to share the feedback from the kind of audience we have on tonight. It looks like we have a lot of people that have no experience in coding, 21.3%, almost tied with people that would call themselves maybe a level 2 out of 5 coder, so that they have some experience, but still not nearly the expert level or feel super comfortable. So I would say the majority that's with us tonight are on the newer end of coding.
Okay. Don't worry. We'll take good care of you.
And so then I just opened another poll, just like Ann had said. So if you were going to look at this problem and try to write a program to represent ways to solve this problem, think about which you maybe feel is going to be more efficient, and then go ahead and hit submit. Ann, can you hear me?
Yes, I can.
Okay. Kara, can you hear me? Yeah, I think Kara's having a problem with her audio, so we're going to work on that.
Okay.
So while Kara's working with her audio, let me close this poll. So give me about 15 seconds, and we'll kind of tally up the results, and we'll see where everyone's at.
Okay. And do you want me to go ahead while you work with Kara?
Yeah.
Okay.
That'd be great.
Okay. So what did they think here?
So let me publish these results.
So it looks like elimination wins, and yeah, and in particular, this one, is set up very clearly that the y's would cancel out, and my students tend to feel that way too. Although it's very clear that we could solve for y here, and very quickly and substitute it in here. But most of us who are mathematicians, I think that a lot of us have a little bit of OCD, I would think, and we like to keep things neat and organized. And I think that's why a lot of us like um, elimination and even matrices. I don't know if you saw that I named my daughter after Sir Arthur Cayley, and one of the reasons is because Sir Arthur Cayley was the first person to put systems of equations into matrices to solve them. I don't know if you guys knew that, but he was. In any case, she doesn't tell people that because she's an artist now, but let's move on. So my students, wanted to make a general way of doing this because I know we could just add these up and the y's would cancel out. And then once we solve for x, we could substitute the x value into either one of these equations and find the y value. But they wanted to have a procedural, I'll use a different word, a procedural way of doing this no matter what these numbers were, like no matter what number was here and what number was here. So like the worst case scenario would be that these didn't cancel out and these didn't cancel out. So they did some problems and they said, what if we just didn't see that these canceled out and we wanted to eliminate the x's? Well, we could multiply this one by this value here and multiply this equation by the opposite of this value here. So that's what they chose to do. And so that we didn't have to do any sort of substitution, then we would do, I'm going to cancel out this pole. Then on this equation, we would do the same thing. We would multiply this equation by whatever this coefficient was, and we would multiply this equation by the opposite of this value. And I know it's kind of hard to see with the two choices that we have here. And so you can see here we would get the value of y because we've eliminated x. And here we would get the value of x because we've eliminated y. And they did this several times to see that it worked out no matter what the equations were. And so then they generalized it by putting in variables a, b, and c, d, e, and f. And they attempted to do the same thing. So in this equation, if we want to eliminate x, they multiplied this equation by d and this equation by negative a. And here they multiplied this equation by e and this equation by negative b. I hid a lot of the messy arithmetic that they were able to come up with because, of course, if you have negative or if you have AD here and negative AD here, the x's cancel out. But the math to get what you get here was a little messier, of course. And the same thing here. Is Kara back on yet, Mike? He's muted.
Yeah, she's not muted. I think she's going to switch her audio over. So just give her another minute.
Okay. I'll let her get on. She was going to comment about something, and I don't know if anybody else noted anything particular about this. But so this seemed a very programmable way of doing things. So if we wanted to use this, we would just need to know what the A, B, and C were, the D, E, and F, and then we would have our outputs. So this is the first program we're going to write tonight, and it's going to look something like this. So we're going to need to be able to ask the user for these values, and then we're going to store these values into our y and our x, and then we're going to display these. And so I'm going to show you some things to do. Now, if you have a TI-84CE, I will show you some shortcuts. If you don't have a CE, I'll show you how to do it the long way. And if you don't have a calculator with you, you can just follow along and do this later at your own leisure. So I'm going to pull up my calculator, and I got to do it one more time. Okay. Okay. Where did my calculator go? I'll just do it the long way. Okay.
Can you hear me, Ann?
Yes, I can. Do you want me to go back?
Fantastic.
Okay. So I'm going to go back to the slide real quick because I wanted her to say something about, we were just talking about this earlier, and she made a comment about this results down here. And I was like, oh my gosh, you are correct.
Yeah, so I was just noticing that it looked like your students discovered Kramer's rule on accident, maybe, because the solution they have there for y looks like it's the determinant of the coefficients of x along with the coefficients of y replaced with the constants.
Right, because they put the C in the F in place of the Y's right here, right?
Mhm.
Yeah.
Yeah. So I didn't notice that till you pulled this slide up. Thought it was pretty neat.
That is pretty neat. I don't think anybody ever derived Kramer's rule for me. And so now I'm pretty excited because I was like, where did that come from? You know, it's pretty cool. So see if we get it back up. Okay. So if you've never programmed before, that's okay. This is my TI Smart View, and I hope all of you have that. It's wonderful. And we're going to program on here first, and then I'll show you TI Connect later on tonight. So this is your program button right here. It says program, and when you push it, well, it doesn't say program. It has PRGM. But if you hit the button, you'll see that I have a lot of programs. You may have a few, may not have any at all, and that's okay. This is where you execute a program or run a program. My students are like, oh, you're going to kill your program. No, we're going to run a program. You're going to edit a program if you had one created and you wanted to fix it, or you can create a new program. And so we're going to create a new program. Now, I have one already called Elimination 2, so I'm going to call it something else tonight, because if you already have one called that, you can't call it again, or it'll just pull up that same program. Now, the name of your program, I'll show you here in a minute, but all you need to do right now is just hit Enter. You will see this A is blinking, which means your alphabet is locked. If you ever want to lock your alphabet any other time, you have to hit this second and this alpha. It says A lock for alphabet locked. And so what we want to do here is we want to name our program. I'm going to call it System 2 for System of Equations, two variables, two unknowns. That's what I'm going to come up with. If you want to call it Elim 2, because that's what I called it in the slideshow, that's fine, or whatever you like. Now, the alphabet is these green letters above the keys, and you should just be able to push them. They are not in QWERTY, which I just hit the wrong button, because then it wouldn't be allowed on exams. So you have to do alphabetical order of all things. Now, if you want the 2, you will have to hit your alpha button to turn the alphabet off and do this. You can only have 8 letters for the name of a program, and as we found out earlier, your program has to start with a letter. It can't start with a number. Okay, so this is what I'm going to call my program, and I'm going to hit Enter, and you will see that your program name is here, and you should see a colon. Each line in your program this is called a command line, so each command that you want your program to run must have a colon. So the first line in our program is clear home, and it's not really necessary to have clear home, but as I said, I have a little bit of OCD, and so I like the program to start with a fresh home screen, you know, so the calculations you'd been doing before aren't there, and it just starts out pretty. So I'm going to show you how to find clear home. So remember we hit program and it pulled us into that first menu. Well, if we hit program now, we're going to get new things. It's going to give you the things you can do while you're inside of a program. So when we hit program now, we get new menus up here. These are, if you know much about program, these are your if, then, else, for, while, and different things. This is your input, output menu. If you have a color calculator, you're going to have color. This is executing a program with inside of a program, so like a subroutine. And then if you have a CE, this is going to allow you to do things with your TI Innovator or your Rover. And so if you have those things, this will allow you to control those things. So what we want here is clear home, which is number 8. So we're going to choose number 8. That will clear your home. And then you hit enter to get a new command line. Then we want
to...
Yes.
And while you're working, somebody mentioned that they're on a TI Inspire CX2. And I think what we can say to that is a lot of the programming language is the same, but there are definitely some differences in how you get things done in a TI Inspire. So
yes.
Learning on a TI-84 isn't going to be a bad thing, because you're going to learn, you can watch and learn some things here tonight that you could apply, that you'll have to get some other resources for the Inspire.
And I'll show you a site here in a little bit where you can teach yourself and your students how to program from the beginning. Okay, so I'll show you a link here in a little bit. Okay, so if you hit program now, we want to prompt the user to enter the A, B, and C. So prompt is number 2 here. And then we're going to have to hit alpha to get A. And then the comma is its own button. It's right here above the number 7. And then we're just going to keep going. Alpha B, comma, alpha C, comma, alpha D. And we got to go all the way to F, comma, alpha E. Oops. And it's okay if you do something wrong. This happens all the time. I just did something wrong. I'm glad I did something wrong so I can show you what to do. I'm just going to hit enter, and I'm like, oops, I made a mistake. Delete. So here's a delete, and above it is an insert. And so I sometimes have to use that because nobody's perfect. If you think you are, you're probably wrong, right? So I'm glad I made a mistake so I could show you what to do to fix it. Although Kara's sometimes perfect. What do you think, Kara?
Yeah, not even close.
Okay. So that's our first line. I hope you guys are caught up there. Now, we want to take our calculations that we found on our paper, and we want to store it in our variables. So it's a lot of stuff. It looks to type, but here's our parentheses. And so let's just make sure. Now, there's no pretty font here. If you guys are used to your alpha F1 to make your pretty fractions, you can't do that here. You have to do the old school way with the parentheses and the order of operations. So we're going to do that here. And the calculator does know that CD means C times D, so we can just do that. So we're going to do alpha C, alpha D, minus alpha A, alpha F. Close your parentheses, hit your divide key, and then we'll do parentheses, alpha B, alpha D, minus alpha A, alpha E.
So, Anne,
yes.
The calculator knows that you need to multiply C and D. When you just write CD, it already assumes the multiplication, correct?
Yes. Now, I know that on the Inspire, for our Inspire user, variables on the Inspire can be CD. You can name it as CD. So in the Inspire, you would have to put a time sign.
Perfect.
Okay. Because variables in the Inspire can be like a whole word. Does that make sense? On the 84, a variable is a single letter. Okay. And so here is the store button. This is how we store this calculation into a value. So it's STO store, and I'll give you this arrow. And then we're going to store this one into Y. So alpha Y, way down here. Now, if you have a TICE right now, then we can copy this line and then just change it to the letters we need it to be, which will speed things up a little bit. If you do not, just hit enter and just start typing. I just want to show you this shortcut. If you do have a CE, you hit alpha F5. You can copy this line, which is number 5, and then you can paste it below, which is number 6. And now it's not what you want, but we could change it to be what we need it to be. And it may save you a little bit of time, maybe not. Maybe in this case it's not that great, but you can just type over. So we want it to be CE minus BF, and then this would be AE minus BD.
And so just to make it clear on the TI-84 plus, this copy and paste option is not possible.
No, it is not. So in that case, you would just have to type it again. You just have to enter and type everything again for the new line.
Mm-hmm.
This is all new on the CE. Okay, now this is the user-friendly part. Yes, I know. I just saw her. I was like, oh my gosh, copy and paste. I just learned this last March at the T-Cubed International Conference. This is why I go to the conference every year. I learn something new every year. And my students think I'm so geeky. I'm like, we're not having class for 2 days because I'm going to go to a graphing calculator conference. And they're like, what? Why would you want to do that? And I'm like, because I learn something new every year. Okay, so program. We're going to display now, I/O. This is the display. We're going to display something to them. And if you ever want to display words like hello or do something here, it has to be in quotes. So if we want to display something, we're going to hit alpha in quotes, and we're going to display. So we're going to tell them that this is their answer. And so we're going to have, so this isn't actually going to display the value of x. It's going to display ordered pair x, y.
So if it's in quotes, it's actually going to show up on the screen exactly what you have inside the quotes.
Yes, whatever's in the quotes.
Even though you've stored some numbers into x and y.
Yeah, now if I wrote right here, display, I'm just not going to do the fraction part right. Well, maybe I will, because we'll see it later without it. Now we'll do program, display, and we're going to display x. Now this would display the x value. Because I didn't put it in quotes, it's going to display the value. Does that make sense?
Perfect, yeah.
This is going to display the ordered pair x, y. This is going to display whatever this value is. And then I'm going to change it to a fraction so that it will come out nice and pretty in case we want it as a fraction. You didn't have to put this part. You could have it come out as a decimal. It's up to you what you want. You could leave this part off. Then we're going to display y as well. Yes, ma'am.
And you got the fraction by hitting math?
Yes.
Yeah, you're going to do it again here, right? Math.
Yeah. Fraction. So now this program is done. Oh, that's beautiful.
What do you guys think? Yeah.
That's an extension that guy just asked. I said, that's an extension that I'd want you to work on. What was that question?
What did he ask you? What did he ask you? Because we can't see it.
He said, how would you program in unknowns and in equations?
Nice.
Yeah, that's what you get to ask your students and yourself, and then email it back to me, okay? This is really nice. This is what my students came up with, and what we're going to do is execute this. Now, if you have a CE, remember you could execute it right here under number 1. Just for everybody else's sake, I'm not going to do that. Well, I guess I'll do it here. Well, I'm just going to quit. Just for, if you have a CE, you can do that. But I'm just going to quit out of here so I can show everybody how to do it from the home screen. Because if you don't have a CE, you can't execute from the F5 menu. So once your program is written, and I just want to remind you, somebody asked me to slow down. Remember that we have this recorded, and you'll get all these programs sent to you, and we'll show you how to get them from the computer onto your calculator as well at the end. So to run the program, you just go to Program, and remember I have all these programs. You want to find whatever you called your program. Mine is called System 2, and I have so many programs. I'm going to hit Alpha S and find my program. So I still have a lot of them. So I'm going to scroll down until I find the one that I called System 2. And I'm going to hit Enter. And this is what it's going to look like on my home screen, which is like, okay, it's not doing anything. But that's because I've just called it up onto my home screen. And so then I have to hit Enter. And Kara, could you read the coefficients of the problem we had? Do you remember what it was? Okay.
Sure, yeah. So the coefficient of x was 2.
Okay.
Coefficient of y is 1.
All right.
And the constant is 15.
All right.
And then the second equation is 3, -1, and 5.
Make sure you use this negative or it'll get mad at you. And so see how it prompted for each of these, the program? And now it should tell you that the answer was 4 and 7. So did we do it right?
That's what you got, too. Yes.
That.
Awesome.
So it's kind of cute. The kids liked it, and it was fun for them to do it. And again, it was the students who came up with that.
Fantastic.
Do you want to add anything there?
I'm just curious if this is what some of the participants were expecting, or do you think this is too simple, or do you also see ways you could extend this? So just if you have thoughts about that, we'd love to hear your thoughts in the chat.
Okay. Do you want me to go on?
Sure.
Okay. So you were going to talk about this part, weren't you? And you're going to point out my mistake. So again, nobody's perfect, but just bear with us.
Both Ann and I agreed that this is something we still teach our students with quadratics. We really like to show them where the quadratic formula comes from. And if it's not my favorite day in Algebra 2, it's one of them. I think students are just marvel at how you can derive this. And so over to the right, we have the work of how you generalize the quadratic formula from completing the square. And over on the left, we have a specific example that's a little bit harder, completing the square. In fact, it's so difficult that we have a slight mistake. So you can find that mistake later. Not super important, because what we want to focus on is the general method over to the right, and then take this to the program.
Here's the mistake, kids. I'll point it out. I made it. I didn't take half of 3/2 right there. Bad math teacher, but hopefully, your students would yell at you and say, wait a minute, you didn't take half. So just ignore that and just fix it later. Just realize we know we did the bad math, and we are good mathematicians who know we made a mistake. All right. I just want to say it out loud. Go ahead.
But before you start, somebody's asking what grade level your students were. You mentioned that you teach college. I'm assuming you did that in something like a college algebra class.
Yes, and intermediate algebra, which is the class before college algebra. So that would be, I don't know, like Algebra 2 and Algebra 1 for you guys?
Yeah, definitely. I've done things like this in Algebra 2, even Algebra 1. Mm-hmm. And I taught a class for a while that we called Transition to Algebra, which is kind of those juniors who are having trouble. And they like coding too. So I think, the door's wide open to who might grab onto this.
Now, this is one thing we're going to talk about this one. We're going to go ahead and do this program because there's a reason that sometimes the students don't pay attention as they're doing this one. And this is a really short one. And so it's a good practice for us. And I think people can join in on this. There's several things that they make mistakes on this one. And maybe you guys can share where, if you've done this, what are the mistakes students make? Okay, and let's try to see if you can think about ahead of time, even if you haven't done this, where do you think, even though it's a short program, where mathematically where the students make a mistake? So let's go ahead and get back to the calculator. See, I do have OCD. I just don't like a messy screen. Because I'm going to go to Program, and we're going to create a new program. And I know that I have this called many different things. I have it called Q form, quad form. So call it whatever you want to call it. I'm going to call it QD form because I'm pretty sure I've never called it that. So we'll see. We'll make sure that it comes up different. QD form.
Somebody mentioned a mistake, and that people make with the quadratic formula in general is if it's not in proper order with x squared and then the x term and the constant, then people assume the first term is always a. So that's not necessarily a mistake in the coding, but it's certainly a mistake. I agree with how people do the quadratic formula.
Oh, good. I never called it that. Okay, so what we need them to tell us is what A, B, and C are. So what would be wrong with that mistake would be even if you wrote the program correctly, then that would be user error, right? Even if the program worked and it was a perfectly good program, it would be what we call garbage in, garbage out. That's
exactly. Perfect.
GIGO is what my computer science teachers used to call it, is if you put garbage in, you're going to get garbage out. So the program's not going to work if the students don't understand the mathematics, right? Even if you write a perfectly good formula program, if they don't know what A, B, and C are, then they can't use the program. So it doesn't even matter, right? And this program will only give approximation for irrational solutions. And so if you want them to give exact solutions, it's not going to give exact solutions. So they can only check irrational solutions. Does that make sense? Okay, so we can even try that here. And then another thing that happens with this program is if your solutions are imaginary and your mode's not set to imaginary, it will say error. So maybe we should try all of those things. So let's start with a program. And I actually didn't put clear home on this one. I'm going to fix it. So I'm going to put 9, clear home.
8.
Yeah, 8, sorry. When you're teaching your students, this is one thing T-Cubed has taught me, is I could just push 8, but then I'd be going faster than you want me to. And so it slows me down to actually go down to that. So that might be something you do with your students. Yeah, you could set imaginary numbers right there inside your program. That's what someone just messaged. And so let's do a program, input, output. Let's prompt our A, B, and C, just like we did on that last program. So alpha A, the comma is right above 7, alpha B, comma, and then alpha C. Now, I know my voice is kind of annoying and childlike, but I'm actually 51 years old. I don't mind telling you. But I am going to sing to you right now, okay? So we know it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, correct? So we're going to do that, but we can't do plus or minus at the same time. So you want to do plus first, then you can do that. Or if you can do minus first, you can do that. It doesn't really matter. And so if you look, we're going to have to make sure the calculator knows the order of operations because, again, we can't do the pretty font. So we're going to do parentheses for the numerator, and the parentheses are their own buttons, and then negative. This is where the students make one of their first mistakes, is they use a minus sign instead of a negative, so make sure they're paying attention. Alpha B, negative B, plus or minus, you choose. And then we're going to have to do our square root. Second, square root. Some of my college algebra students still have an 83, so then it becomes a whole other discussion. Then we have alpha B squared minus 4AC. Now, here's where another error comes. We have to close this parentheses, and then sometimes the kids don't close this parentheses. So that's a big deal to make sure you close all those parentheses. Now we want to divide by 2a. So what do you think happens here is if I just wrote 2A. What is the issue?
Well, I think that's what most of my students do, and then they raise their hand and complain because it doesn't work. So I think probably there's some coding issue.
I just saw no problem when A is 1. That is correct. If A is 1, it's not a problem. But if A is anything else, yeah, because it's going to divide all this by 2 and then multiply by A. Because order of operations, that's the problem with please excuse my dear Aunt Sally, is that kids think that multiplication comes before division. And so they think that it's going to multiply this before it divides, and that's not the case. It's going to divide and then multiply. And I taught with this guy from Mexico City. Here, this is something I want to show you real quick. Second insert lets you put that parentheses in even if you forgot the first time. So that's nice too. So not only do you have delete, you have insert. And then we're going to store this. And I chose M and N. You can choose whatever letters you want. Store that into M. Now, if you have copy and paste, use it. If you don't use it. Now, you have to be on the line that you want to copy. I'm going to use it just for time's sake tonight. Those of you who don't have a CE are like, oh, I wish I had one now. And then you do paste the line below, number 6. And what's nice about this now is I can just go over here and again make sure you use the right sign because now I do want a minus. And then the last thing we would need to do is display our M and N. And so program, display, alpha, M, comma.
I think you want to go up and change that second M to an N.
Yes, thank you, ma'am.
You're welcome.
And so this time, instead of quitting out of the program, I'm going to pretend that we all have CEs. But if you don't, you would have to quit out of this, go home, and then execute the program. Okay, but let's just see how cool it is. In a CE, I can execute the program from here. And so I'm going to hit alpha F5, and I'm going to execute the program. So we all know what the solution to x squared minus 4 is. So I'm going to hit 1, 0, negative 4. And we see we get something like that. But I'm going to show you what happens if you hit, again, you can just hit enter and it'll run again. 1, oh, maybe I didn't say that. The programs continually run until you do some other calculation in there, as long as you just hit enter. I'm going to do 1, 0, negative 5, which we know the square root of 5 is not a pretty number. So that's what we look at. And if the kids wanted to know if they had the right answer, they could do the square root of 5 and see that that's how they could check it. Now I'm going to have to go to the program, or you could hit second enter to pull up the program again. So that's a way to do it so you could not have to go back through and search for your programs. If you have a lot of programs like I do, this is how I do it.
So second enter pulls up an entry that you've previously put in on your screen.
Yeah. So let's do 1, 0, positive 4. So this is telling me that I'm in real mode. And so I'm going to quit out of here, and I'm going to go to my mode, and I'm going to put it into A plus BI. And then I'm going to get out of there. I'm going to run the program again. 1, 0, 4. And now it gives me the right answer.
That is so cool.
All right. Okay. Next is this one that's
so
one of my, yes, ma'am.
Yeah, I was just going to say we've only got about 11 minutes left, so maybe we'll just show them some of the other ones that we have and make sure everyone understands that you're going to get all these programs in a file after the webinar is over. And once you start to develop a sense of how to program, you'll find everything in those menus that Anne's been showing you, the IO menu and the control menu, and you'll be able to search for the commands that are in the lines of the programs that we're sending you, or just use the programs that have already been made.
Yeah. So my students wrote a program for finding the vertex of the parabola. You know, we always give it to them that it's negative b over 2a, and then you stick negative b over 2a into the function, and you get your y value. But they wanted to write a program, so they did this. So again, I'm just going through it quickly, and you can see how simple that program is, and they displayed h and k. And then this one, you want to talk about this one real quick?
Yeah, I really like this one because I think I teach calculus, and I think it just ties together the graphical representation and the numeric representation and the algebraic representation of the derivative for students. And I like it as opposed to just showing them a table, because a table is pretty overwhelming of the secant slopes, the limit of the secant slopes approaching the derivative. And so I like it that we can just model what's happening step by step. So do you just want to show them real quick how this one works?
Sure. Okay, so we put this function into here. This is our function. And then I'm going to go to the program. Again, it's way down here under my S's. But I'm going to run it. And so let's say we wanted to know what was happening as we approach 3 from the right. So we could put in 3 and 3.1. And we could see what we're getting, and then 3 and 3. Oops, sorry. Dang it.
Okay. Trying to get to the second entry again.
Yeah, 3 and 3.01. And so we had 12.61 here. Now we have 12.061. So now you hit enter to keep the program running. That's what I didn't do the first time. 3 and 3.001. So if you've ever seen a calc problem where they say fill out this table as the numbers get closer to 3 from the right, then this is what my students wanted. They wanted something that would do that for them, because it was like, this is getting really tedious. And so they wrote this program. My calc students did. I'll just get really close. And you can see that it's approaching 12. So that's the end of that one. So let's go to the next one. So then they were like, well, why can't we just put in a list, keep this A fixed, and put in a list for B? So they wrote this program next. So they put all these numbers closer and closer to A from the right and from the left into list 1. And then into list 2, they did Y1 of list 2. And
so for all of these programs, and for all these programs, you have to define your function first, right? Your students didn't make it fancy enough where it would ask for the Y1. And you can do that, but it's fine that they just knew that they were going to have to use it by putting in the function first.
Right. We tried having it prompt for Y1, but it tended to make Y1 look really funny, because you can't enter Y1 with the pretty font if you prompt for it. And so it caused a little issue sometimes, especially when you wanted to do a rational function or something that needed the pretty font. So maybe what I told my students is maybe they should put a friendly line in here that said, display, please make sure you've entered your function in Y1. And then they would remember, or maybe say, be sure you've entered your function in Y1, just to remind themselves that they needed to do that first. But they never seemed to forget, so it wasn't a problem. So this one would let you look at what was happening as you got closer and closer to like an asymptote from the right and to the left. And then this would let you look as you get larger and larger, so as you approach infinity. And then as you see, this is the opposite of what's in list 3, so this would be as you approach negative infinity. So I'm going to let you go on from there.
Okay. Would you be able to let me share my screen real quick?
Of course, if I remember how to do that. I say stop sharing, and then I let you share. Oops. With the ball. Yes. You should be sharing now.
Okay. Awesome. So I'm just going to share a couple of things where I've used an activity off of TI's website. So this airport impact study comes from the activities on TI's website, Activity Central, and this is a TI-84 activity under Algebra 2. And when you click on the rational expressions activities, you have the ability to download all the activity that goes with this impact study. And basically the activity, I've pulled up the teacher version of it, and the activity has the students enter data into lists, and then just using their home screen, they're trying to see whether the activity tells them that it's either inversely, the intensity of the sound at an airport is either inversely related to the distance or it's inversely related to the square of the distance. So in seeing how this activity works, my students wanted to write a program about testing for inverse relationships. So I just want to model that with the other activity that we do together about blood alcohol. So the students go to this website and they find the blood alcohol content. I give them some parameters of a 100-pound to a 200-pound person, and they get their data from the website. And this file will be available to you if you'd like. But then they test out their program with inverse relationships, and I'm just going to show it to you and show you and model that you can actually ask the calculator to input a list, and you'll get this file so you can study this program and see it's a really pretty simple program. But it's asking you for the two lists of data. So this is the blood alcohol data, and it tests whether x times y is a constant. It pauses for a minute for you to be able to see whether x times y looks pretty constant, and it looks, well, maybe it's kind of close to 9. And then it lets you test, if you press enter here, whether x squared times y is a constant. And this one's a little bit more obvious that probably it's not inversely related to the square of your weight. So this one is your weight versus your blood alcohol content. And then it asks you just a question to think about, and then what is K? So I think probably it's the inverse relationship that we saw at first, and K is probably 9. So I just tell the computer, and then I have to actually type in the function that I believe is happening, which is 9 divided by x. And it does remind you to put it in quotes, because if you don't, it doesn't work. And then it will ask you, okay, so what is a blood alcohol content that you're curious about? And 0.08 in Illinois is the legal limit for blood alcohol. So they type that in, and it says, well, the first relationship is the one that we thought was happening, is that you're not going to be legal to drive if you weigh 112 pounds. If you weigh less than that, definitely not. And if you weigh more than that, you would be. So this is all based on the parameters that were set up in the problem, and you could change those for sure. So that was just a nice application for us to use programming for. And here is the program. Pretty simple, but it has a few more complicated things in it.
Then we just have sharing. Yeah, go ahead.
Yeah, just going to show some of the other programs my students have written with graphic art. And this is kind of a popular thing that people do, but you can see some of the math that goes into actually solving for some of the intersections. The big thing for me with this project is students really, really hit home the idea of domain and range and trying to find intersections. This was in an Algebra 2 class, and you can see that it wasn't really that easy. And then this one was in a transition class, transition algebra, so we stuck with just lines. But this student was getting a D in my class, and the mom came to parent-teacher conferences and says, "What have you done to her? She was up till 3 in the morning working on your project." So anyway, this is just some of my student work here in the PowerPoint that you're going to get later. And then, Anne, I think you were going to model real quick how to do the TI Connect software.
Yeah, I don't know if we have time, but TI Connect software is free, and I just want to show you real quick that programming in here is very easy because you just open in here and you can just copy, and you can also just type. And so this is freeware. You can see this is Maggie that she had, and it's so much easier to type in here and then send it to your calculator. There are directions for this. This is Baymax that
Can
you
you
saw.
share your screen?
Oh,
Can you
sorry.
share your screen real quick? That's okay.
Yeah, maybe I can. Share my screen, screen one, sorry. So here is, this is Maggie, this is Baymax, and I gotta get rid of this thing. This is Baymax, and there's Steam. This was a Steam thing. This is a very simple programming. You can just display like something simple on your screen and there. But all the commands and stuff are here under Program, and so it's nice because you can just type them or you can use them. And you can copy and paste lines, very simple. I could just highlight this whole line and copy it below. And so even if you don't have a TI-84 CE, you can program in here and send it to your calculator. So the last thing I was going to show you is, I know we're running over here, is what I told you about,
Sending a file, is that what you want to show them?
Yeah. Yes.
How to send a file? Yeah.
About T cubed. Now I can't see up there.
The 10 minutes of code.
education.ti.com. If you don't know about that website, which obviously you do if you came here. If you go to activities and you go to TI codes, you can teach your kids can learn how to program. So there's TI codes for the TI-84 or the Inspire for the Inspire person we have tonight. And so these are really great ways for your kids to learn how to to code. And then if you have an Innovator Hub, you can do that there too. Okay. So.
Perfect.
Okay.
Thanks so much, Karen Ann, for everything you shared tonight. We did mention at the very beginning of the webinar that one lucky winner tonight is going to receive a T-Cubed International Conference registration, and tonight's lucky winner is Olga Lopez. So Olga, congratulations. We hope to see you as well as everyone else at the T-Cubed International Conference. And Olga will be following up with an email here in a few days to give you a little more information.